Howdy, 8th grade. Today we are going to be looking at something that is adding radicals. Friendly reminder, radical here just means a square root. So a radical is just a square root. And so we are going to learn how to add and subtract them today. We've already done some multiplying and dividing, and we found that was pretty easy. So I'm going to start off reviewing that a little bit, and then we're going to get into how to add and subtract these radical expressions. So we're going to start off with a little bit of review on multiplying. Fair warning, they just upgraded the program I use to record these, so I have all sorts of new colors, so I might get very excited about those. We're going to start by reviewing multiplying these radicals. So if I have two radicals, like the square root of 25 and the square root of 6, the way I would multiply these together is that I would just multiply the insides. So this would be square root of 25 times 6, which would be the square root of 150. And yes, we can simplify that, but for now I'm not going to. I just want to show you guys how to multiply these. When you multiply them, they just multiply on the inside. It's really, really easy. Adding and subtracting is a little more difficult, as it always is, which is kind of sad. So adding and subtracting. I have like 6 different shades of green on here. It's awesome. I'm going to try them all out at some point during this video. But for now, we're going to stick with this red. Adding and subtracting, how is it done? And good news, we've done something that looks almost exactly like this, and that is factoring. Yay, factoring. So when we see these problems, we can only add radicals together if it's the same radical. So what that's going to look like is if I have 2 root 7 plus 4 root 7, these radicals here are the same, so this can give me 6 root 7. And that's just because those radicals are the same, they can combine and it works out. So moving on, if I have something that looks like 4 square root of xy minus 2 square root of xy, once again I have the same radical here, so I have 4 minus 2 is 2, and I keep the radical. So if you notice, the radicals stay the same in all of these equations. And for adding and subtracting, that's normally what's going to happen. So I'll try one more real quick. If I have the square root of 2, 6 root 2 plus 8 square root of 11. These are not different radicals, which makes me sad. So these are different, so I cannot add them. Cannot add, and it'll just stay 6 root 2 plus 8 root 11, and that's how it will end up. That is as simplified as possible, so that is already simplified. So what we're going to want is like what we had up here, same radicals, if I can spell radicals, that makes us happy. Down here, if they have different radicals, we can't add them together. They are already simplified. So I want us to try something else, which is going to be 3 times the square root of 8m cubed plus 2. I'm going to do this in a different color so we can tell that it is a, let's do this green. Kind of a darker green, haven't done that one before. 3 root 8m cubed plus 2 root 2m plus 4 square root of 2m. So I said this looks kind of like factoring, which we've done before. So looking at this like factoring, what I want to start off doing is factoring all these radicals. So this ends up as root 2 and root m. So root 2m goes to 2 and m. 2m goes to 2 and m, 8m cubed, which is going to be 3 different m's, and 8 is 4 and 2, 4 is 2 and 2. So after I factor all these, I can rewrite these as radicals that I've factored. This is 3 times the square root of 2, times the square root of 2, square root of 2, square root of m, square root of m, square root of m, plus 2 root 2 root m, plus 2, or plus 4, sorry, 4 root 2 root m. And what I want to do is to see what these all have in common. And I can sell it right here. I have a root 2m, root 2 root m, root 2 root m. So I'm going to pull that out. I'm just going to put that off to the side. And I have square root of 2 root m. And then I'm going to multiply it by something. So we're factoring this out so that if I distribute this in, I'll get back to what I started with. So we're going to go one term at a time. And I'm just going to pick up what's left here. So that is going to be 3. Root 2 times root 2 is 2. Root m times root m is m. Plus, what's left here is 2. What's left here is 4. And just like that, I am pretty much done. I just have to simplify what's in here. 3 times 2 is 6, times m is 6m, plus 2 plus 4 is 6, and that's going to be multiplied into 2 and m, so that would be square root of 2m. If we wanted to, we could have also factored the coefficients out front here, and that would have given us m plus 1 times 6m eventually. 6 square root of 2m. So I just pulled the 6's out, giving me m plus 1 times 6 times root 2m. I have 6 times root 2m, and that'd be all done. But this right here is the final answer, or this. There's a couple different ways to write it. They're the same thing. That's all right. But this is kind of the generic one we're going to go with, because that's the way we can get to with our algorithmic way of working through this. So we'll continue a little bit. I want to try one more problem. So we are going to do C. Let's do this in this last green color, kind of an olive green. Great colors. C root 75c minus the square root of 27c cubed. So the first thing I'm going to want to do is to factor. So my factors here are going to be 75c, which is 25 and 3. 25 becomes 5 and 5. And this one becomes 27c cubed, 9, 3, 3, 3, and c cubed is going to be c times c times c. Factoring is always exciting. Let's keep on chugging. So I have my c out front, which I'm going to keep. Then my radical here became square root of 5, square root of 5, square root of 3, square root of c. And I am subtracting over here my square root of 3, square root of 3, square root of 3, root c, root c, root c. And just like that, we are now ready to take out what these have in common, so that we can factor them together and figure out how to simplify this. So what they have in common is going to be this c right here, and this 3 right there. If I wanted to, I could divide this c. And instead of writing c, that's the same as square root of c times square root of c, which is perfectly okay, and that would give me a couple more that I can factor out and make it look a little bit nicer later on. So I have root c, root c, root c, and root 3 to take out. So I have the square root of 3 times c times c times c, and that's going to be all into root 5 minus root 3, root 3. So if I keep on going with this, I will get square root of 3 times c times c times c is going to be the square root of 3c cubed. That's going to be multiplied by 5 minus 3. Or if I simplify it all the way, I would get 2 square root of 3c cubed, because 5 minus 3, of course, is 2. So I hope that y'all are good to go there. And I'll see y'all in class. We'll practice this a little bit more. Again, it's just factoring it out so we can simplify it a little easier. And that's pretty much what we're doing. So it's a bit of a repeat of something we have seen before, but getting to use it again, this time with radicals. Anyways, I will see y'all in class. Have a wonderful evening. Oh gosh, it's going again. Sorry, new program, still trying to figure out the kinks. I thought that was the save button. Evidently that starts up recording again. I will talk to you all soon.